Question number 1. A small stone is projected vertically upward with speed 20 meters per second from a point O, which is 5 meters above the ground. The stone is modeled as a particle moving freely under gravity. Find the speed of the stone at the instant when it is 2 meters above the ground. To start the math, so let us first draw the situation. So we were told that a particle was thrown vertically upward and it actually came down to the ground. Now the particle was initially 5 meters above the ground, and as we are dealing with both up and down direction of movement, so we are taking the upward as positive, all upward variables as positive and downward variables as negative. So our u was 20 meters per second and u was actually thrown in an upward direction. As a result, u will be taken as a positive variable. Now we were asked to find the speed at the instant when it is 2 meters above the ground. So if this is the ground, now 2 meters above the ground will be actually maybe here. Okay, so the ball must be at this point where it will be 2 meters above the ground. So at this point, what is the displacement of the ball? The ball actually moved from initial position to a downward direction of 3 meters. So our S will be minus 3 meters. Our U will be 20 meters per second. Our A will be minus 9.8 meters per second square, because in both the direction of movement the acceleration was actually the gravity was pulling the ball downward in both the situation, when the ball was actually moving up, even when the ball is moving down. So our A will be minus 9.8. okay, so we are asked to find the speed. So we can use the formula v square equals u square plus 2as, and we will get the value of v from using this equation. So our v will be 21.4 meters per second. Now question B. The total time between the instant when the stone is projected from O, that means they are asking from here, and the instant when it strikes the ground. So basically when he was the ball was actually here. So in this situation, the ball actually moved in a downward direction for 5 meters. So for part B, our S will be minus 5 meters per second. U will, sorry, not meter per second, it will be meter. Our U will be 20 meters per second and A will be minus 9.8 meters per second square. So we are required to find the value of T. T is our required. So we can use the formula S equals to ut plus half at square. Now just put in those values. So you will get an equation of 20t minus 4.9t square. So 4.9t square minus 20t equals 0. From here, if you solve the quadratic function, you will get two values of t, which will be 4.32 and minus 0.24. I'm not showing how to solve the quadratic equation. I think every one of you are able to do this. So time cannot be negative, so our required time is 4.32 seconds.